Day 55, naming minerals. I'm going to be making this video when there are other students in the classroom, so sorry for the noise in the background. But there's a little activity. We're going to be finding all the different properties of a mineral and using them to figure out the name of it. I'm going to work through all the different tests for one mineral, and then if I have time, I'll go back and do others. So the first one that we're going to be doing is this mineral right here. So go ahead and write down the color of this. I hope that with your machine you can see that it's a silver color. But that is the only answer that I'm going to give you. Next we have streak. So let's take a black plate and rub on here. And we cannot really see any color on that. So let's go on to the white plate. And you go ahead and write down the color for that. That is the streak. Step 2. Step 3, the luster. Remember, there are two kinds of luster that we're going to be talking about in class. One is metallic and the other is non-metallic. So you tell me, is this metallic or non-metallic? Number 4, cleavage or fracture. These are the different kinds of breakage patterns. So cleavage is when we have very, very flat sides. They might be tiny flat sides, but still flat. It'll look like a jewel of some sort that's in a jewelry store. Or fracture. Fracture is completely all random, no flat sides at all. It's all rough like a piece of gravel on the side of the road. So you tell me, is this fracture or is this cleavage? Number 5, density. To find density, you have to figure out both the volume and the mass. So let's first do mass. Here's my triple beam balance, and I put the mineral on that side. This end goes up, so I need to adjust this. It's almost there. Okay, so you can read the scale now. This slide is at 70. This slide is at 0. And this slide is, let's get it in focus here. Oh, it won't focus. There it is. There, it's in focus. So go ahead and write down the mass of the mineral. That's not the answer to the density. It's just the mass part. Now the volume. To figure out volume, we first get the graduated cylinder with a little bit of water in it. So the water level here is at, this is 170, this is 180, and then 2 more lines up. Each line is worth 2, so this is 184. That's without the rock. Now I'm going to slide the rock in, and the volume is going to go up. I'm going to try to move this camera a little bit for you. Okay, so now you can see the level. Here is the 190, and each line is worth 2. It goes up to that line right there. So what is the value there? That is the high level. Subtract off the previous low level. The difference there, your subtraction, will give you the volume of the mineral. Write that down in the second line of your paper here. So we have the mass from the triple beam balance. We have the volume from our subtraction. Now for density, you take that mass and you divide it by the volume. Get that number and put the number in that box right there. Lastly, the hardness. The hardness. So we try to scratch it with our fingernail, and I don't get anything off of there. Let's try to scratch it with a penny. And I am getting flecks off with a penny. Let's try with a glass plate. And I am getting flecks. I am scratching it with the glass plate. Let's try the nail. And again, I am getting flecks there. Okay, so look at your hardness scales from your previous packets, or you can follow the directions right here, and you can figure out the hardness of sample A. Sample B. Sample B is this white material here. Okay, write down the color for sample B. Streak. Here's a streak on the white plate. Here's a streak on the black plate. We really don't see much color at all in either case. So let's see here. For color, we have white. For sample B, the streak is none. Luster. Is this metallic or non-metallic? Test number 4, cleavage or fracture. What would you call this? We have some fairly flat sides here, so we're going to call that cleavage. Density. We first have to find the mass. So I put the mineral there. Okay, and 38 grams is too much. That is not enough.
What is that called? Do they make like more of those? Oh yeah, there's
Getting close. We're almost balanced. Okay, that's pretty well balanced. Here is this triple beam balance. The mass is going to be 43.5. The volume. Get a graduated cylinder out again. And we can read that that is going to be an initial height of 166. So I'm going to make a little note of that, 166, and I'm going to slide the mineral in. And now it goes up to 182. So on my paper, I subtract off the high value minus the low value, and I get 16 milliliters for the volume of this thing. So on my paper, I got it all 16. I then divide the mass by the volume, and that's going to be 2.5. hardness.
So then the whole game is in your hands. Hugs.
I try to scratch it with my fingernail, and I'm not making any scratches. My fingernail is 2.5 hardness, so that means that this crystal is harder than 2.5. I then scratch it with a penny. Penny has a hardness of 3.5, and I'm not making any scratches. So that means that the crystal is harder than 3.5. I then scratch with the glass, and I'm not making any scratches. So that means that it's harder than the glass, which is 5.5. And now I scratch with the nail. And I'm not making any scratches there either. So all we can say is that it is harder than 6.5. So sample B down here, greater than 6.5, more than 6.5. So now we go to our chart here, and we try to find what is following all of our discoveries. And we can see that down here we have a colorless streak. We have a hardness that's greater than 6.5. We have crystals. And so this satisfies a lot of the things that we have discovered. So we're going to call that quartz. Let's look at what you had for the first one. Sample A, you should have gotten the, look up here. At the top section, one of these is going to fit best. One of the top 4 for sample A. Figure that out and report to your teacher.